Hi, I'm Bob Powers. I'm with Goliath Historical Fencing Academy under James Riley. And I wanted to record a video today to share with you an insight that I believe I've had into one of the sources in particular, Fiore Deliberies, um, into how I think he understands fencing such that he organized his manuscript to try to kind of reopen the conversation around Fiore, um, how we understand what Fiore is doing, how Fiore understood what he was doing, how we teach Fiore, and how perhaps we need to adapt our thinking about Fiore and our understanding about Fiore. Um, this, I kind of hope to be part of a larger project about how we understand what the texts are doing from a kind of philosophical or epistemological framework. For my background, in addition to studying mostly KDF under James Riley and being an instructor at Goliath, I'm also a PhD candidate in philosophy at Marquette University, where I've taught, and I've also taught at Concordia University, Wisconsin, in the history of philosophy. So what interested me about Fiore's text in particular, and about these texts more broadly, was their philosophy, the philosophical underpinnings and their epistemological underpinnings, and how they thought and how they organized their thoughts according to um, these epistemologies, and what we get from their philosophical underpinnings, what sort of insights we can gather, not only from them about them, but from them about our fencing, about the art of fencing itself, and how we can incorporate that art. So today, I want to talk to you about how swords are Euclidean, about the sort of geometry of swordsmanship and how geometry affected swordsmanship in one of the earliest longsword sources that we have, namely Fiore. So I gave this the subtitle that it's an intuition into the epistemology of Fiore. So I'm not going to give you a strict proof that Fiore thought this way, but what I'm going to give you is a series of examples where we go through some axiomatic systems. We try and understand what axiomatic systems are, what they look like, and how they can be used, and what their limitations are. So what are their goals? What are their limitations? What are their stylistic features? And see if we can learn anything about how Fiore understood fencing from the fact that he uses this kind of axiomatic system. And then as far as the epistemology of Fiore, that's what I mean. How did he understand fencing? How did he systematize fencing in a geometric fashion? Okay, so within that, this presentation's got 4 goals. The first is, like I said, to provide that intuition into the geometrical basis. The second goal is that having that intuition, that insight into what a geometrical epistemology, the use of an axiomatic system, what that entails, that insight will then free us up to make interpretations of Fiore's implicit rules and essential definitions, meaning that when we look at the techniques as they're explicated by Fiore, what we're seeing are exemplars of a larger set of principles, these meta rules that Fiore has in mind that he's trying to illustrate through these plays, right? So what that does is that makes Fiore larger than a bag of tricks. It's not just this set of techniques, 1 through 60 or what have you, right? It's the meta principles that are being illustrated by these techniques, right? And so then that becomes our job to extrapolate what those meta principles are and where in what contexts we can apply these different techniques that might not be explicitly mentioned in the text, but because these techniques are exemplars of larger principles, if we can find those larger principles, we can figure out where else we can put these sorts of techniques and see what other sorts of techniques emerge out of these larger principles. Okay, so I'm hoping to open up a new set of conversations about Fiore in that way. Third, to show that Fiore was way ahead of his time compared to modern philosophy. So this is kind of a side point, but the fact that he had this Euclidean model was 100 years before philosophy did. So Descartes would write about this later, that he wanted to model philosophy off of geometry. Fiore was doing that in the practical arts before Descartes and Spinoza were doing it in the liberal arts. I found that interesting. And then fourth and finally, to allow for an increase in abstract thinking about the art of swordsmanship. So to, again, give us sort of permission to start thinking about these things in terms of abstract ideas and comparing those to the concrete practicalities of the actual sword fight. So allowing the practical art to be a speculative art, to be what we're going to call a virtually practical or habitually practical art, where we think about fencing, we see what sorts of conclusions we reach from our theoretical framework, and then we can test it out and see if that's actually the way that swordsmanship works in reality. Okay, so 4 goals. It's quite large for one presentation, but hopefully we can get through all of that together. So there's an interesting line in Filippo Vadi that Greg Malik keyed me into that says, "From geometry, all fencing is born." So how do we understand that phrase? From geometry, all fencing is born. Perhaps we might think immediately that what Vadi has in mind, or if we read back into Fiore, that what Fiore might think if we were to ask him, what does geometrical fencing mean? We would be inclined to think in terms of lines and planes and angles, right? If somebody cuts down this line, then we move, to cut down the same line or down a different line, or maybe we take a step to change the center line and take such and such an angle and, present along such and such a plane, right? So, and that's all true, that swordsmanship is geometrical in that fashion. But I'm going to suggest here that it's geometrical to these authors, or at least to Fiore, in a different way. Okay, so again, that not only is it geometrical in the sense that it uses shape and angle and things like that, it's geometrical in that it's an axiomatic system, in that it understands fencing the way that Euclid would understand geometry, and that has some implications. So Euclid's elements are presented in terms of an axiomatic system. And an axiomatic system, generally speaking, has 3 goals: completeness, independence, and consistency. Now, we know today from Gödel's incompleteness theorem that you can get one or the other of these, but not all of them, right? It can be consistent, but not complete, or it can be complete, but not consistent, or not independent. So for Fiore at this time, he was not aware of that. And the assumption for the longest time was that Euclid in his elements had accomplished all 3 goals. And we can sort of intuit that any axiomatic system of fencing is going to have to eliminate, or at least elide, kind of round off and assume certain things about the human body that may or may not be true, right? There's always going to be assumptions made that aren't going to fit into the particular. Like we're talking about the general, we're not necessarily going to be specifying all the particulars. Usually, for instance, when we're thinking about fencing, we're thinking about 2 able-bodied people, probably male, probably right-handed, probably around the same size and weight. And those things might not be true, right? You might be fencing with a left-handed, differently abled person, right? That changes the nature of the positions that they're able to get in comfortably, right? So so as far as completeness, Fiore system would probably miss the mark in terms of that. But what it gains from rounding off and making these provisional assumptions is a sense of its own interior consistency and a sense of completeness, insofar as what it gives you is all of the options. Given those provisional assumptions, it gives you an entire framework of fencing. So again, as I said before, if we're talking about plays, these plays aren't just individual tricks about like a very specific set of stimuli. What they are is they're meant to represent the pieces of a complete axiomatic system. Okay. So since it has the goals of an axiomatic system, there are certain goals that it does not have. So when Euclid's writing his elements, he's trying to be complete, independent, and consistent. Now it turns out he's not able to, and we've got, who is it, Euler and others that go on to expand mathematics, like mathematics on a sphere and things like that, geometry on a sphere and things like that. So, but with that, with those goals, we know that he does not have the goal necessarily of teaching geometry, right? He has the goal of laying out as systematically as he can the complete art of geometry, the complete science of geometry, but not necessarily about teaching a particular student. So how you use Euclid's Elements as a textbook to teach geometry, if you were to do that, and you would have to come up with a series of overlaying meta rules to give to the student. And I'll try and show you some examples of that, specifically from logic. I'll try and show you some examples of these types of meta rules that are in the examples I'm going to use are mostly just like hacks. But we'll try and see how this would be applicable in a historical fencing context when we look at Fiore. So the way that we organize something for completeness is going to be different than the way that we organize something in order to give somebody an insight. So in order to teach somebody some lesson, we're going to organize the phenomena in a particular way that lends itself to them having that insight. But if what we want is the complete system, then we're going to organize the same data, the same set of phenomena, but we're going to organize it in a way that gives the entirety of the picture. And I'll try and show what that insight organization and that completeness organization look like as we go through. But suffice it to say, there's a kind of medieval principle that says that things better known in themselves aren't necessarily better known to us. So the way that we understand something is not necessarily the way we learned it. Right? The best way of organizing data for completeness is not necessarily the exact order in which you learned it. Sometimes you go from back to front, right? You learn something step 1, step 2, step 3, step 4, but then if step 4 is the most important part, you remember that part and then go backward, right? And you organize the data in exactly the reverse order that you learned it. So it's not necessarily the case that Fiore set out these plays in the way he wanted you to learn them. It might be the case that he set out the plays in the way that makes the most sense internally, but not the way that presents the insights he wanted you to have, right? So if you were at his school, he might not be reading from his book, if that makes sense. Okay. So this is particularly true of the difference between an insight and a proof, right? Even in this presentation, I'm trying to give you an insight. I'm trying to teach something to you. I'm not trying to prove something to you. If I were presenting you my proof, I would be going much more rigidly, much less extrapolation, and I'd organize it in a much different way. Okay, so now that we have the idea of what the goals of an axiomatic system are and what the goals of an axiomatic system aren't, we've already maybe got some insights into how we might need to approach Fiore from a exegetical standpoint, from a pedagogical standpoint, etc. let's take a look at axiomatic systems and what their pieces are. What do they look like from kind of the inside? So in order to do that, I'm going to present you one philosophical basis of arithmetic. It's not the philosophical basis of arithmetic. It's just one. There are many. This one I get from a philosopher, 20th century philosopher called Bernard Lonergan, in his book Insight. So Lonergan breaks up these systems into terms and operators, and he'd include logic in that. Terms, in the case of arithmetic, are going to be your pieces. So imagine like chess, you have the pieces, those are the terms, you have the moves that the pieces can make, those are the operators. So in terms of arithmetic, the pieces are numbers and the operators are those symbols that represent the functions that you can perform on the numbers, right? The plus sign, the minus sign, the equal sign, the square root sign, things like that. Okay. So the meanings of the terms and the operators are defined by their relations. What a king is its ability to move in a certain pattern, and it being the most important piece on the board, right? As far as checkmate or whatever. What a queen is her ability to move in a certain pattern on a chessboard. Okay, so same thing with when you're thinking about the counting numbers. What the number 2 is its position in relationship to all the other numbers according to those operators. Okay, and then that's grounded by the insight into this the entirety of the system. So the result, or so the terms are defined by the operators, such as the result of an operation is a term, the result of a term, and the term is in turn the result of an operation. Those two things define each other. The operations are defined by the systems of rules, so that what is done in accord with the rules is an operation. So these three pieces are grounded in the understanding of the entirety of the system. The system makes sense once you understand it as a whole. So the question becomes, how do you build up to the system, and how do you obtain the rules? So I say the trick is to obtain the rules which ground the operations, which ground the terms. So if we're talking in terms of fencing already, right, we can think about the positions as the terms, the transitions between the positions as the operators, and then the rules become, how do we know which transitions to make at which time? Okay. So what is going to happen then is, as we explicate through these plays, in this time the phrases are going to be arithmetic phrases, right? They're going to be addition and subtraction and things like that. What we're going to obtain is what Lonergan calls a higher viewpoint, that through the proper understanding of their relations in terms of operators, in the language of operators, I should say, the relationship between the terms in the language of operators, you obtain meta rules, and then those meta rules lead to higher and higher sets of meta rules. So let's see what that looks like in arithmetic. So as with all insight, there's a presupposed knowledge that you have coming into that insight. So even in relationship to this video, I've said I'm trying to give you an insight into Fiore. Well, you already have the prerequisite knowledge of who Fiore is, most basically, some level of swordsmanship, some level of the English language. There's a certain prerequisite set of knowledge that you have that comes from your previous experience and previous insights that go into the current insight that you're trying to have. And this is also going to be true with Fiore and fencing. So fencing requires a certain set of prerequisite knowledge. Okay, so when studying Fiore, we shouldn't shy away from the fact that we have prerequisite knowledge, that we have previous experience that we're building on. That's something that can be embraced even within the context of an axiomatic system, because axiomatic systems depend on these provisional assumptions. as we'll see. So the provisional assumption in arithmetic is the counting numbers 1, 2, 3, 4, 5, 6, 7, 8, etc. Right? And here we have our terms. So these are the pieces that we're going to manipulate in order to do arithmetic. And we already have this word etc. And the etc. is already doing some work, which means that this thing is going to continue past what I've said. Right? So there's more to the story that could be communicated, but I don't have to communicate that more. Right? I don't have to explicitly count to all the counting numbers in order for you to understand what I'm getting at. Once you know how to count, you know every counting number up to whatever the highest iteration is that you know, right? And then you know that you could always add one. Okay. And so, and here you have, you know, then when you examine the relationship to the between the counting numbers, what's the most basic relationship between these terms according to my prerequisite knowledge? You know that it's adding one. Okay, so you have these two first operators, this plus and equals. So you have 1 plus 1 equals 2, 2 plus 1 equals 3, 3 plus 1 equals 4. And then here you have this etc. again. Okay, I have the insight. I get how the system works. I understand something about the meta rule, although I haven't articulated it yet. I understand something about the meta rule that says that I can keep doing this and one and keep getting higher and higher counting numbers theoretically ad infinitum. It's limited only by our language, by our ability to label them. Okay, so you have this first insight into the basis of arithmetic, this relationship, this initial relationship between these terms. So you have this first operator. And from this first operator, you get this higher viewpoint, which is this meta rule that we'll call addition. So you take from the table the fact that 2 plus 1 equals 3, right? You know this because you know the relationship between the counting numbers. And then you say, well, I know that I can do this plus 1 thing, right? That operation is available to you. You have this rule that says that you can do that because it's a counting number. And so what you can do is you can add 1, 3 plus 1 to one side of the equation, and 2 plus 1 plus 1 to the other side of the equation, right? So you added plus 1 to both sides of the equation. The equation stays equal because you understand what equal means. Okay, so from the table, you then get this idea of 4, 3 plus 1, go back to the table, is 4, equals 2 plus 1 plus 1, 1 plus 1 is 2. So 4 equals 2 plus 2. Okay, and we could keep doing that, and I could keep giving you examples, et cetera, et cetera, et cetera, and you have an insight into the higher viewpoint of addition. So now you understand a new set of meta rules that we call addition. Okay, and that et cetera, et cetera, et cetera represents the continuity of the insight beyond the examples given. Okay, and then you can get subtraction by doing the same process in reverse. Gives you the higher viewpoint of subtraction. And if you iterate the process, right, 2 plus 2 plus 2 is 3 times 3 times over, right? 3 times 2 multiplication. Right? 2 plus 2 plus 2 is 6. So 2 3 times is 6. Okay, so we've got multiplication now. Now you have a new operator and a new higher viewpoint, a new meta rule. And then you can keep doing that, et cetera, et cetera, et cetera. So what does it look like if you iterate multiples? Okay, that looks like powers, right? And then if you inverse that, it looks like square roots, et cetera, et cetera, et cetera, until you have the entire science of arithmetic. What that phrase, et cetera, et cetera, et cetera, does, as we've noticed, is it represents insight. It means that you've understood some rule that's articulable, that makes it unnecessary to complete the table. So what it does is it grants completeness to the system. right? So in an axiomatic system, one of the goals was completeness. Well, once you understand addition, you no longer have to continue adding, right? If I were to give you any addition problem, provided you had pen and paper, you could theoretically do it. So Lonergan will call this it entering the habitual texture of your mind. So it becomes a habit that is in your mind, to where if I gave you a random math problem, say 3,687 plus 842, you could do that problem, even if no one has ever explicitly asked you that before, because it's such a random math problem that like I don't ever remember having to add that in particular. But I have 100% confidence that if I had a pen and paper and you asked me that math problem, that I'd get it right with zero doubt in my mind. So the completeness that makes it so that you don't have to fill out the rest of the table also gives you a sense of certainty that the rules are going to cover these, et cetera, et cetera, et cetera, these situations that have not yet arisen. Okay. And so an interesting question that you might be reflecting on now is, okay, is that also true of Fiore's fencing, that he covers situations not explicitly mentioned in the text through that, et cetera, et cetera, et cetera, right? If I know a particular technique, can I use it in contexts not explicitly mentioned by Fiore? Right? One might think, of course, but you know, that's not um, that's not always understood. Somebody who limits themselves to the techniques in the text might wonder how one gets to the technique if, let's say, if the other person doesn't cut in first, if they wait for you to cut in first, but you want to do a counter to them cutting in first. Well, as long as you understand the particulars of the blade geometry, it might not matter who cuts in first, as long as you have the initiative, as long as it's your turn. So maybe there are other ways of getting to these same plays that might not be immediately obvious, right? It's particularly to somebody who's learning according to the text, sort of by rote. Again, because that might not be what the text is designed to do. So this, et cetera, in addition to granting insight and completeness, it also allows for the emergence of these higher viewpoints, these new rules. Okay, so we can start thinking about what are the meta rules. Okay, and just as in the examples I gave you the example of addition, I gave you the example of subtraction, I gave you those explicitly, but I also showed how implicit in those examples are even higher viewpoints, powers, roots, irrational numbers, which I didn't cover, which was an enormous discovery to the Greeks, who were not expecting that. They thought that the world was comprehensible according to numbers, and then they came up with a number that was incomprehensible using their own proofs, and they were just faced with the fact that they had to be wrong about their provisional assumption that the world was comprehensible according to numbers. Okay, from the Pythagoreans, who discovered it. So it goes beyond what's explicitly stated in the provisional terms and operators, and then those higher viewpoints are themselves striking and unexpected. Okay, so in other words, what am I driving at? The completeness, independence, and consistency of an axiomatic system grant you the freedom to go beyond the proofs of the text. Okay, the fact that it's an axiomatic system suggests that it needs to be supplemented with previous knowledge. It needs to go beyond the text to higher viewpoints. It needs to fill out the rest of the table with the techniques that aren't included because it's assumed that you understand, or the situations that aren't included because it assumes that you understand. Right. And then finally, that your organization, your pedagogical organization, won't necessarily reflect exactly how you would lay that out in a table. Okay, so I didn't give you a multiplication table. I gave you an insight into multiplication as iterated addition, which is the relationship, which is an explication, an extrapolation of the relationship between the counting numbers. Right. So in providing you the philosophical basis, giving you that insight, I said addition is an extrapolation of the relationship between the counting numbers, and multiplication is the iteration of the extrapolation of the relationship between the counting numbers, right? I gave you that insight. I didn't give you addition tables or multiplication tables. I gave you a small addition table. I didn't give you any multiplication tables, right? That's not the point, right? If I was trying to give you the entire system of multiplication, I might give you the entire table as far as I knew it, right? As far as I could go with it. And maybe that would be a worthwhile project. But for our purposes, much quicker was to give you the insight into what multiplication was. It's much more valuable to you, in my estimation. Okay, which means you can go beyond if you remember that kind of 12 by 12 multiplication table, obviously the purpose of that is to go beyond it. Okay, less obviously in the case of Fiore, right? But that's why I'm trying to draw the parallel. Okay. So let's take a look then at Euclid's Elements in particular. If Euclid's Elements is the text I'm suggesting is the analog to primary analogate to Fiore, let's take a look at the elements. So the elements have terms in terms of 23 definitions. And these definitions take the form of things like a point has no length, breadth, or depth. And these 5 postulates and 5 things called common notions. Okay, and those are the operators. Those are the things that determine the relationships between these definitions. So a point is that of which there is no part. A line is a length without breadth, etc. So let's take a look at, so you have these definitions. You have 23 definitions, 5 postulates, and 5 common notions. So that's it. Those are all the pieces on the board, right? 23 pieces, 10 movement patterns. That's all. And you get, what is it, 13 books of geometry in Euclid? Let's double check that. Yeah, 13 books of geometry, 500 plus pages of geometry, which in itself is an impressive feat, right? But so you take this seemingly simple starting place of 23 terms, 10 operators, and you start running through these plays that for Euclid are called propositions. So you have a goal, which is construct an equilateral triangle on a given finite straight line. And then to obtain that goal, so you start out with a finite straight line AB, and you're trying to create this triangle ABC. Okay. So you use the postulates, which are the operators, right? And you use these definitions, which are your terms, in order to solve that problem, in order to go through that play. Okay. So what you can do with AB is you can draw a circle ABCD with a center radius at A, right? Take AB, use A as the radius, and then draw the circle this way. And you can do that because of postulate 3. So if we run back up to postulate 3 says one of the rules, or one of the operators, I should say, I should be specific about this, right? One of the operations you can perform with a line is to draw a circle with any center and radius. Now here the center is A, and the radius is AB. Okay, center A, radius AB. You can draw any circle like that. That's allowed. That's an operation you can perform. And again, let the circle ACE with the center B, radius BA have been drawn. Postulate 3. So again, same postulate, but different radius, or I'm sorry, different center, right? Center is now B, radius is the same, AB. You can draw this second circle, ACE. Okay, and let the straight lines CA and CB have been joined from the point C where the circles cut one another to the points AB respectively. So you see the point of intersection C, and what Euclid is saying is you can draw a line between A and C and a line between B and C according to the first postulate. So you have this operation that says you can draw a straight line from any point to any point. Okay. And since point A is the center of circle CDB, AC is equal to AB according to definition 15, right, which is one of our terms. So AC has to be equal to AB according to one of our terms, which is definition 15. A circle is a plane figure contained by a single line. All of the straight lines radiating toward the circumference from one point amongst those lying inside the figure are equal to one another. So all the radii of a circle are equal, right? And that point is called the center in definition 16. So the circle's all the points equidistant from a single point on a two-dimensional plane. So we know from that definition that AB is equal to AC. And similarly, we know from that same definition that BC is equal to BA. And we know from the common notion 1 that equal things are equal, right? So because BC is equal to AB and AC is equal to AB, then AC is equal to AB. All three lines are equal. It's an equilateral triangle, right? All sides of the same length. Okay, so what have we done? We've solved a problem using our terms and our operators. Okay, we've successfully solved the problem that we were given. Okay, same thing, proposition 2. So this is going to be a proposition about moving a straight line. And it in turn is going to depend on postulate 1. I'm sorry, on proposition 1. Pardon me. It in turn is going to depend on proposition 1. So in order to move a straight line, you have to be able to make an equilateral triangle. And we've made an equilateral triangle in proposition 1, so therefore we can get away with making the equilateral triangle in proposition 2. We know how to do that. It says see proposition 1 for more details, right? And so what you wind up with is proposition 2, depending on proposition 1, the ability to create an equilateral triangle in order to move line segments. Okay, and then proposition 1 depends on postulate 1, postulate 3, definition 1, and common notion 1. Okay, so all of our propositions refer back to our postulates, definitions, and common notions for their terms and operators, right? They bring those forward into the problem, and then they bring those solutions forward into new problems. So the idea with an axiomatic system is once you establish something, once you prove it according to the axiomatic system, you can then use it in any context you need it. Okay, so again, thinking already about Fiore's plays. If Fiore puts a play in a certain context, he proves that you can perform a certain throw in the wrestling section. Well, if you find yourself in an analogous body position in the sword section, like with long swords in your hand, you can throw the same throw, and it's from the wrestling section, and that's just fine, right? These postulates are meant to, I'm sorry, these propositions are meant to build on one another. Okay, and just like with the arithmetic, there are higher viewpoints involved as we go through geometry. Okay, so if that's what geometry is, that's what it's like, then yeah. So we shows. Sorry. So this shows when we do geometry, we can solve problems using the propositions, and then geometry is not just the doing of propositions, but the solving of our own problems. So now what you can do, now that you understand geometry, is you can use the theoretical geometry in practical contexts. So now let's say you have something like you have some piece of wood and you have a measurement, and then you want to make it an equilateral triangle, but you only have one measurement. And so like you don't have your ruler, right? So you can't pick it up and move it to something else, right? You have like a block and you want to make an equilateral triangle where one of the sides is the length of the of all the sides, right? Well, what you can do, is you can take a circle, right? You could take like a string and a pencil and make a circle, right? Around, but and now you're thinking, well, if you have the string, why don't you just measure the sides, right? But you don't have to do that, right? In this particular case, right? You can bring the abstraction back into the practical. Okay. And we'll actually see why that's valuable. Because if you're thinking, well, you can just use the string to measure the sides, you have a particular bias toward the practical that we're gonna talk about in the later in this lecture, which is fine. But you can see then how that would be applicable in a practical context, even though it is completely impractical. Which actually, let's go back to that real quick, because one of the things I didn't highlight as we were going through it is that these terms are completely abstracted from the practicality. So it's something that I want to hit on later on in this lecture, but you'll notice that a point has no length, breadth, or depth. So going back to Euclid, when you look at the points having no length, breadth, or depth, the lines having length but no breadth or depth, as you look at this image, one thing you'll notice is that this line has length, but it also has height. Now, according to Euclid's definition, a line has length but no height. So then the question is this a line if it has length and height? Now you can see like the height is just really, really minuscule, right? In this case, because it's on a screen, it doesn't have depth. So that's an interesting phenomenon. If I were to draw it in chalk on a board, it would have depth, right? Just the slightest layer of chalk deep, right? So if this has height and length, is it a line? Is it a Euclidean line? So one of the things I'll ask my students sometimes when we're talking about Plato is whether or not they've ever actually seen a circle. If a circle is, like I said before, all the points equidistant from a single point on a two-dimensional plane, and points have no length, no height, no depth. Have you ever actually seen a point? No, I've never seen anything with no length, height, or depth. These images all have slight lengths, heights, and depths, although these have no depths because they're on a screen, which is interesting. But they have length and height. So none of these are points. So this is not all the points equidistant from a single center, right? This is a representation of that. So what is a point then if it's not the physical object that we're using to represent it? Well, it must be some kind of abstract entity. Okay, so what Euclid has done is he's completely abstracted geometry from the shapes that it initially was meant to represent. Okay, so let's consider these shapes irrespective of any material object and see how far we can get in our geometry. And we'll see how that's a huge step forward for geometry in the history of the ancient world. So let's look then at Fiore at the Getty and see if we can see some of these commonalities, these common features with Euclid. Okay, and so here we have in this gorgeous version of the Getty from Wichtenauer, right in the wrestling section, you have these, which comes right after the introduction. So right after the introduction, you get the wrestling section. The first thing you get in the wrestling section are the so-called guards, right, which are these positions that you can find your body in. So already we have this prerequisite knowledge of an able-bodied person, right? Can you put your body in this position? Can you put your body in this position? Okay. If you can, then we will call this position longa, and we'll call this position boar's tooth, I believe. Right. And we'll call this position porta de ferro, which I believe is iron gate. And we'll call this position frontale. Okay. So we have these resting positions, right? Longa, boar's tooth, frontale, porta de ferro. Right. And then, so those are our terms, right? So we have prerequisite knowledge that we bring into the axiomatic system. So starting with as few assumptions as possible, we have 4 terms. And then the operators become the transitions between the terms. So you can go from, he says right here, and from this guard, I can transition to porta de ferro. Okay. Which is the throwing. So from from longa, we can transition to boar's tooth. From boar's tooth, we can transition to porta de ferro. These are the operators. These transitions between the guards are these operators. These transitions between the posti are our operators. Okay, so our terms plus our operators then give us plays. They give us propositions. Just like the definitions and the postulates and the common notions give us propositions, the positions and transitions give us plays. Okay, so you have this first play from the remedy master, where if somebody goes in on a longa, right? And basically what the person's trying to do here from a wrestling context is get you in a kind of an underhook or an overhook, and then turning their hips and throw you over their hip, right? In a pretty basic like judo style throw, if you can conceptualize it that way. So what you can do in response to that initial incoming longa is you can comport your body in the boar's tooth in response to that longa, basically taking on kind of a whizzer, right? And you can press that grip this direction, right? And from that first play, we then build up to this second play, which is a throw from that, where you can wrap your arm over the longa and go down into porta de ferro. Right? Now, if it happens that as he's presenting his longa, he misses getting his overhook, right? So he doesn't get it, he doesn't get his arm around your neck. Instead, as you present his your boar's tooth pressure, he slips to this side of your neck to prevent that prevent getting thrown, basically to prevent that pressure. He gives to that pressure. He responds to it softly, right? Gives to that pressure. What you can then do is pull his arm across your body, grab his knee, extend out from your boar's tooth to your longa to porta de ferro, throwing him over your right knee, right? So these are the first 3 sort of postulates, the first 3 sort of plays in the wrestling section in Fiore. So then I'm going to go ahead and fast forward a little bit to the 12th scholar in the 15th play. So here we have somebody who's coming to grips with both arms, wrapping them around your head, right? So it's kind of a double longa. And what he says is essentially comporting yourself in a boar's tooth, attack his face over that longa. Now, when you attack his face over that longa, what's he going to do with that longa? Right? He might weaken it just like before, right? He might go from here to here so that he can give and get out, right? If he does that, you can also transition from here into the third play of the apprezzare, right, of the wrestling. So what's happening In the wrestling section, the 12th scholar, the play 15, is referring back to the third play, the second scholar. And the second scholar is building off of first and second play. And those in turn depend on the terms, the guards, the posti, and the transitions, the ability to move from posti to posti, posta to posta. This is also true in the sword section, right? That what does he do? He starts out with the guards, then he talks about the cuts and the thrusts. The cuts and the thrusts are the transitions between the guards, and with those two pieces, the terms and the operators, he then sets out his plays, his postulates. Okay, and what should then be emerging are these meta rules, right? That kind of like, how do you get into the position where you can do the third play, the second scholar? How do you get into the position where you can do the second scholar of the wrestling? Well, you get into that position anytime he's got an overhook on you and weakens that overhook. Okay, so it's not just when he goes from longa and then weakens responds to the pressure, gives to the pressure, right? It's literally anytime you find he's going from longa to some other position, giving up that kind of overhook around your neck, you can then go to the third play, right? So that might be something like a rule of thumb. Okay, so what do we get from this? We get from this that Fiore is not just a bag of tricks. He includes the definitions of terms and operators with some explicit rules in the plays, but those plays, like the propositions of Euclid, they're meant to be illustrative of these larger patterns. However, like Euclid, they're attempts to solve specific problems, give examples, and build out a system that then is meant to be extrapolated on and applied, right? And so the et cetera, et cetera, et cetera, right? So he gives you enough to get an insight. And then once you have the insight, you then apply the insight to the particular circumstances, right? Even so far as the particular circumstance, meaning like you have to do it with your body, right? You have to come in with prerequisite knowledge. You have to do it with your particular body, which means that there's going to be these problems of translation between the universal and the particular, right? Between the general and the specific. Okay. So these plays explicate what it is to fence the same way the propositions of Euclid explicate what it is to do geometry. So doing geometry isn't just going, okay, proposition one, and then writing it out, proposition two, and then writing it out. That's not doing geometry. Doing geometry is solving problems using these kinds of methods creatively in your own head, in your own physical application, using your prerequisite skills and abilities, right? Euclid was a great cornerstone, a great like monument, touchstone, I should say, in the history of geometry, but he's not the be all and end all of geometry. There was geometry before Euclid, there's geometry after Euclid. Same thing with Fiore. Okay, so hopefully you can see already that Fiore's Euclidean base is not just a geometrical expression of fencing in terms of figure, like I was talking about before with Vadi, but what I've called a geometrical epistemology, that he's understanding this according to an axiomatic system. In other words, the principles of what result from these principles, what results from these terms and operators and the implicit meta rules is a complete, independent, and consistent axiomatic system of Fiore longsword. Okay, and then it becomes up to us to continue to elaborate that system, both by expanding it and by teaching it, by bringing in our prerequisite knowledge, by making it by presenting it in a way that lends itself toward insights to students, et cetera, et cetera, et cetera. Okay. So before I continue with the slides, what might an example of such meta rules look like? Well, I know for logic that there are certain kinds of logic problems that suggest to themselves certain techniques of proofs. Okay, so here I have from chapter 8 of a book by Howard Pospisil called Propositional Logic, appropriately enough, by Howard Pospisil, some strategies for primitive inference rules. So if you have a certain kind of thing you're trying to prove, if your proof has a certain kind of goal, then you can suggest these kinds of strategies. Now, these ones are very basic because this is very early on in a very basic logic textbook, symbolic logic textbook that's designed to teach you symbolic logic. But you can see that if your goal is a conditional being an if-then statement. So if you're trying to prove that an if-then statement is true, right? If it is cloudy, then it will rain, right? Then one technique you can try is not 100%, but it's like a heuristic, right? It's like, okay, you see a problem that looks like this, try this kind of solution, is to make a provisional assumption of the antecedent, which is the if part. Okay, so assume that it's cloudy then, and then see if you can get the consequent out. See if you can get rain out of the clouds. Okay, so you have this series in Pospisil of possible strategies. So you have your axiomatic system. You've got your letters that represent your propositions. You've got your ands, your ors, your ifs, your if-thens, your arrows, and your ergos. And from those terms and operators, you get all of symbolic logic. So what you do is you translate the regular spoken language argument into the symbolism, into the symbology, and then from that you then use the operators on those terms to try and get the proof that you want. Okay, so here's some strategies on how to do that. If the goal is a conditional, let's say, like if the goal is to have an arrow in it, an if-then statement in it, then what you might try is a provisional assumption. Okay, and see if that works. So going back to Fiore, if you find yourself in a position where he's got some kind of overhook on you, what you can try is pressuring that overhook and seeing if he slides it off in response to that pressure. If he slides it off in response to that pressure, great. Throw him over your leg. If he doesn't, great, bring him to the ground. Now put a sword in his hand. Okay, fine. Same thing, right? If somehow he rushes in and bear hugs you, right? See if you can get your arm in before that bear hug. Put some pressure on. See what he does, right? Can you bring him down? Do you need to, or does he yield to the pressure, right? Different context, same move. Dagger, same story. Different context, same move. Okay, and then those aren't in the longsword and dagger sections that I'm aware of. They're at least not in the Getty. So anyway, what does this look like in practicality? So if you assume, so here's a problem again from Pospisil. If you assume that if K is true, then A and B follow, and if K and A and B are all true, then W will follow. Can you prove that if K then W is true? So this is your goal. Your goal is if K then W, and this is what you're given. So you're told that these two things are true, and you can kind of intuit, right? Like, okay, if K is true, then A and B are true, and if all three are true, then W is true. So it seems like this should be true. You can kind of intuit that already at the outset. Okay, so, but how do we actually get from this to this step by step? So again, going back to Pospisil, he gives you these strategy suggestions. Okay, well, try making the provisional assumption of the antecedent. The antecedent in this case is K. So we'll try using K as a provisional assumption and see if we can get W. All right. And this is what the proof looks like at the end. This is the number of steps. This is the assumptions that the steps are dependent upon. So you're given 1 and 2 in the argument, right? That these two are true. So as long as your answer is only dependent on one and 2, you're good. That means it's correct. And you provisionally assume K. That means that anything that depends on 3, you don't know if that's true or not. You're just assuming it. Okay, so these are given. This is assumed. Okay, so if K is true, then you know that A and B is true from 1. Okay, so if 3, then you know 1 because of the if-then statement. That's what this says. If you take 3 and you put it into 1, then you can arrow out, you can conditional out the result, right? The consequent, I should say. So if K, then you get AB. If you get AB and you already have K, then you have K and A and B. Okay, from 1 and 3, right? From 3 and 4, and then it's reliant on line 1 and line 3 in your assumptions, right? Okay, so what does K and A and B give you? K and A and B gives you the antecedent in this conditional, all right, which then in turn gives you W. So if K and A and B, then W. Okay, you know that. So in other words, going from 3 to 6, if K is true, which we're assuming it is, but we don't know. So if K is true, then W is true. In other words, if K, then W, or what you set out to prove. Okay, so this was a really brief illustration, only meant to show you how you can take these axiomatic relationships, these terms and operators, and you can come up with strategies about how they tend to interact. And these represent sort of loose meta rules, right? Not as rigid as in the case of arithmetic, but more like general suggestions. Okay, again, thinking about Fiore, not just a bag of tricks. What does our job then become when we're reading Fiore, if we're trying to teach Fiore, if we're trying to fence according to Fiore? Well, one of our jobs is to derive these possible meta rules. Okay, so Fiore is not just a bag of tricks. Continuing on with this, if doing geometry, if you're still doing geometry when you're not going through a postulate or a proposition of Euclid, then it stands to reason that you're still doing Fiore style swordsmanship, even if you're not doing a Fiore specific play, as long as the understanding of the system is there and it's a deliberate but creative adaptation of the system, right? You're doing what you're doing on purpose. So this differentiates a couple of different kinds of fencing. Like if you're looking at 2 novice fencers swinging swords, they might accidentally do something Fiore, but you wouldn't say that they're fencing Fiore. Okay, if you look at 2 students, 2 intermediate fencers, deliberately going through plays like kata, right? You would say that they're fencing according to Fiore in one sense, but you might even say that they're not fencing in another sense, right? Because there's no creativity there. But I mean, kata have their place and they're useful tools, and I'm not trying to say anything about that. But you can see how like that's doing Fiore, but that's a very limited idea of doing Fiore, right? Running through a very specific play on purpose is a very limited idea of Fiore. So what you can do is then think about 2 advanced fencers sparring creatively, where things are going to just come up fluidly, in the particularity of their specific fencing bout, right? So they're not doing any particular play, but they fence according to a system of meta rules, so that if they find themselves in certain kinds of situations, they can act according to the way that Fiore would generally prescribe. Again, not in a particular play, but according to those kind of elaborated meta rules that an axiomatic system suggests. Okay. And just again, just like with Euclid's elements, you can try and teach geometry according to Euclid's elements, or you could reorganize it doing geometric proofs in a different way that's more pedagogically appropriate to the prerequisite knowledge of the person that you're dealing with, right? What skills and abilities are they coming in with? Well, we're going to adapt our teaching to that. Okay, so what's going on here is an axiomatic system, not a pedagogy. So, although it's possible to go through the plays one by one in a kata style in Fiore, and it definitely has its place, same thing with the elements, they definitely have their place. That might not necessarily be the best way of pedagogically teaching Fiore. And again, we can see that because the goals are different. So feel free, I would say, to skip around, do things that aren't from the manuscripts, bring your other knowledge to bear, that sort of thing. I think the fact that it's an axiomatic system suggests that those things are okay. And I think that we might have the tendency to think because it's an axiomatic system, it's not okay to do those things and still call yourself a Fiore fencer. I would actually say it probably is okay. In fact, according to the way that an axiomatic system works, that et cetera, et cetera, et cetera, you are supposed to bring in previous knowledge. You are supposed to fill out the table yourself. You are supposed to do things that aren't necessarily on the table, right? You're supposed to come up with these higher viewpoints. That's sort of part and parcel of an axiomatic system. Okay, so I want to take a brief detour and just look at how this Euclidean model was unique to Fiore, that Fiore was years ahead of his time. So it might strike us that, like, well, Fiore had access to Euclid. It's not unreasonable to think that he modeled it off of Euclidean geometry, but it's wild to think that he was able to think of it. First of all, he thought of it 100 years before they thought of it in philosophical circles. So taking a look real quick at Descartes, Descartes says in his Discourse on Method Rightly Considered, I have ever remained firm in my original resolution to suppose no other principle than that of which I have recently availed myself in demonstrating the existence of God and of the soul, and to accept as true nothing that did not appear to me more clear and certain than the demonstrations of the geometers had formerly appeared. So Descartes has this insight. He's like, well, if I want to prove something, like, let's say, the existence of God and the soul, as he does in his Meditations, if you've ever read the Meditations, the I think, therefore I am, right? What's he trying to do there? He's trying to prove the existence of God. Well, if he's going to do that, he wants to model that off of the geometers. Now, there's a funny thing about the Meditations. The Meditations were written for a Jesuit audience. Jesuits are the Society of Jesus. They're a Catholic community, Catholic order, largely of priests, but of monks and friars, that sort of thing. Are Jesuits friars? I think they're friars. I don't think they're monks. I think they're friars. I think Jesuit friar. Dominicans are friars and Franciscans are friars. I think Jesuits are friars, but I'm not 100% sure about that now that I'm saying that out loud. Regardless, since it was meant for the Jesuits at the university, here's a proof of the existence of God. He modeled it not only off of Euclid's Elements, but off of an Ignatian spiritual retreat. So the founder of the Jesuits is St. Ignatius Loyola. St. Ignatius would do these meditations in his called spiritual exercises, in his retreats that he would give. And so he modeled it off of an Ignatian exercise, an Ignatian spiritual exercise, and he called it the Meditations. That's why it begins in this meditative, I'm sitting alone in my room and the fire's going, and I decide to dispense all of my previous knowledge. So he doesn't present it in the way that Euclid presents it, but he does try and build the way that Euclid builds. So he begins with, I doubt everything. And then he has the insight that there's a relationship between me and doubting. That means that if I'm doubting, then there must be a me, and that me must be thinking. Even if I'm being deceived, I have to be thinking. So we have two things that emerge from the previous knowledge of myself doubting everything, which is me and thinking. And that gives him his first definition, which is that I am a thinking thing. I'm the kind of thing that thinks. And then he has to go from there to prove that he's also the kind of thing that senses, to prove that he has a body. So he proves that he has a mind, but now he has to prove that he has a body. And along the way, he has to prove the immortality of the soul and the existence of God in order to get his body back, which is kind of wild, right? He starts out with, I am a mind, but how do I know I'm a body and not a brain in a vat? Okay, well, I got to prove the existence of God, and then from that, I'm going to draw myself out of it. But anyway, Spinoza was very impressed by the idea of the demonstration of the geometers, but very disappointed that the Meditations was written after this Ignatian spiritual exercise and not after Euclid's Elements. So he went and tried to rewrite essentially Cartesian philosophy, but according to Euclid's Elements, and he came up with his own philosophy, which is Spinocism. But you can see here, part one concerning God, definitions, 1, 2, 3, 4, 5, right? 8 definitions, axioms, right? 7 axioms. And from these definitions and axioms, he's going to prove these propositions, right? Proposition 1, substance is by nature prior to its modification. This is clear how? From definitions 3 and 5, right? He's doing that same axiomatic system that we've seen several times over already. Okay, so philosophy begins to treat itself axiomatically 100 years after Fiore does. So that's interesting. So how does it that Fiore has this insight into fencing, that fencing can be an abstract axiomatic system 100 years before the philosophers think about it? And you think philosophy, you think abstract, right? And you think fencing, you think concrete, you think practical. So he's abstracting a practical art. Well, it's interesting that he would use Euclid as a model, because Euclid himself represents a major leap in his science, in his art of geometry, that took place between the Egyptians and the Babylonians on the one hand and the Greeks on the other. So looking at the history of mathematics, then what did Euclid represent? He represented an abstraction of a practical art. So the Egyptians and Babylonians also had advanced mathematics. They had gotten very far, but theirs was all based on practicalities. Why do you need mathematics? Well, you need mathematics for building a house, making change, dividing up inheritances, et cetera, right? Running a business. So similarly, by analogy, fencing is a productive art. It's something done. It's not something thought about necessarily, right? You can learn fencing and get very far without ever thinking about it in terms, in these abstract Euclidean terms. Same way you can do mathematics and get pretty far. The Babylonians and Egyptians had highly advanced calendars and built advanced structures and the pyramids and all sorts of things, but they never abstracted it from the things that they were doing. And the insight that the Greeks had then is, like I said before, with the points and lines, is that you can think about math in an impractical, abstract way, and that was a good thing. That was a good thing to do. And as a result of that impracticality, as a result of valuing the impracticality of it, they were able to make enormous strides, enormous achievements in geometry and mathematics in general, beyond the Egyptians and the Babylonians as a result of that. Okay, an example of this in Plato, as far as the Greeks valuing this abstraction, Plato says we must endeavor that those who are to be the principal men of our state, right, leaders, should go and learn arithmetic, not as amateurs, right, not as craftsmen, not practically, not like the Egyptians and the Babylonians, and not like even Greek craftsmen, right? But they must carry on the study until they see the nature of number with the mind only. Just like we talked about that point is not the representation. That circle is not the representation on the screen. That triangle is not the representation on the screen. These are pure abstractions with the mind only. Arithmetic has a very great and elevating effect, compelling the soul to reason about abstract number and rebelling against the introduction of the visible, tangible objects into the argument. Right? Don't think about the actual triangle. Right? When I was talking about the piece of string that you could use to make the circular, it's like, don't think about measuring the triangle. Think about equilateral triangle, irrespective of the actual triangle you have in your hand, right? That's an enormous insight that you may or may not have in high school, right? When you're doing geometry, that like, oh shoot, when I'm measuring these, or that when I'm dealing with these geometrical shapes, what I'm doing is precisely not measuring to prove that the sides are equal. How do I prove that the sides are equal? Precisely without measuring. Right? So in my estimation, implicit in this decision to present the system axiomatically is this insight that swordsmanship can and maybe even ought to be treated as an abstract art. That this is something that not only is done, but is thought about, and not only is thought about in terms of real physical bodies, but it is thought about in terms of idealized bodies, right? Mental entities, the same way that it was in geometry. So in the same way that mathematics could only advance when it was brought out of the context of the practical, in the same way, fencing could only advance in Fiore's time if it was brought out of the practical. And Fiore was the one to do that. And that's like, I'm stunned that I'm just stunned at it. Like the genius of that is just mind-blowing. So swordsmanship is a practical art or a productive art. It's an art that's meant to do something, right? It's not, strictly speaking, a liberal art, the way that like we talk about philosophy as being something that's abstract, right? It's not an abstraction in itself. It is meant to be a productive art. So that introduces for us a kind of tension already, where it's like, okay, we want to be able to think about these things abstractly the way that Fiore does, but we also want to be able to do them with our bodies. Right? So there's this kind of tension here. So like, how do we, so to start out with, let's talk about how do we even classify this? Like, we're going to think impractically about a practical thing. Like, can we even do that? And what does that look like, right? Are we turning a practical art into a liberal art? And I'm going to take a suggestion from something I found in Aquinas and De Veritate, which is something he calls a habitual or virtually practical knowledge. That you have the knowledge such that you could do something, you just may or may not actually do it or be doing it, right? So again, it's that et cetera, et cetera, et cetera. Could you add 3,864 plus 5,752? Sure, you could. Are you actually doing it? No. So you have habitual practical knowledge as opposed to actual practical knowledge, right? Lonergan's phrase was, it enters the habitual texture of your mind. Lonergan is very clearly borrowing off of Aquinas in using that language. Okay, so it's knowledge that would be practical but remains unapplied. So that's the kind of knowledge that you're gaining as you're going through the abstract systems. So what we're doing right now is, in a sense, developing our habitual practical knowledge, so that we have a way of looking at Fiore such that eventually it'll lead to practical insights in something we can actually do. Okay. So ironically, I said before, we have a kind of, when I was talking again about the string and the measurements of the triangle, we have a kind of predisposition to saying, well, just measure it, right? We have a predisposition toward practicality. I think that's also true in our fencing right now, as in the sort of broader historical swordsmanship community, that we have a tendency and emphasis toward the practical. And ironically, it's Descartes that begins the process of modern practicalization, practicality, in terms of mathematics through the development of the Cartesian coordinate system. So mathematics went through a period of concrete mathematics in the Egyptians and the Babylonians. Then it went through a period of abstraction in the Greeks through the Middle Ages. And then in modernity, it went through a period of concretization. And at each one of the shiftings between concrete and abstract, it led to an enormous increase in mathematics. Now, abstract mathematics has been going on the entire time. I mean, I mentioned Euler earlier. There are abstract mathematicians still developing proofs and things to this day. But what we have inherited, I believe, is possibly a predisposition toward the practical. And in HEMA, we've I mean, sort of in the history of modern HEMA, like so since the 90s through till today, or whenever you start your history of HEMA, there are periods where we go through heavy emphasis on practicality, where we've used tournaments as our testing ground. Like look, your interpretation, your interpretation of this text either works or it doesn't. And if it works, it'll work in a tournament. And if it doesn't work in a tournament, it's a bad interpretation. Or maybe we shouldn't be using the texts at all, and we should just be doing tournaments and seeing what emerges sort of naturally, and things like that. We have both sides, which emphasize the use of the texts, and sides which emphasize the use of tournaments. And there's sort of always the sense of concretization. It should work, right? So generally speaking, we don't emphasize abstraction, but are focused on practicalities. And there's a reason for that. Mathematics straddles both worlds, but we need to recognize the importance of the abstract as a corrective for our tendency toward the practical, just in the same way we have to recognize the practical as a corrective for our tendency toward the abstract. So that you don't think that I'm favoring abstract over the practical, here's a line from Jonathan Swift from Gulliver's Travels, talking about the people that live on the floating island, right? That again, their island floats above the earth, and their heads are always in the clouds as a result, right? And so they're obsessed with abstraction. And Gulliver says of them, their houses are very ill built. The walls bevel without one right angle in any apartment, and this defect ariseth from the contempt they bear to practical geometry. So they're good Euclideans, right? But the problem is that they can't build houses as a result, right? Which they despise as vulgar and mechanic, those instructions they give being too refined for the intellectuals of their workmen, which occasion perpetual mistakes. And though they are dexterous enough upon a piece of paper in the management of the rule, the pencil, and the divider, again, this is Euclidean, these are the tools of Euclidean that with which you can represent the operators of Euclidean geometry, right? Yet in the common actions and behavior of life, I've never seen a more clumsy, awkward, and unhandy people, nor so slow and perplexed in their conceptions upon all other subjects except those of mathematics and music. Right? So you can be so abstract that you lose track of the practical, but you can also be so practical that you're stunted in your growth, right? One way of thinking about it might be this, that you can only advance in your art if you have abstract insights, partially because you have to see the road ahead. You have to be thinking, okay, what does improvement look like? Right. And so if you have a larger roadmap in terms of abstraction, then you can pursue that. Okay. So a question then is, could historical swordsmanship, our swordsmanship in our particular art, expression of the art, could it benefit from periods of abstraction? And this is where what I'm trying to drive at is that this black and white thinking of it's either abstract or it's concrete does us a bit of a disservice, because these two things don't belong in strict opposition. Instead, I want to run you through a quick thought experiment that says that the characteristic of insight, or it is characteristic of insight, that it pivots between the concrete and the abstract. Okay. that part of understanding is moving back and forth between concrete and abstract. That's actually fundamentally true of particular insights that particular people have, as well as we've been looking at the broader sciences, right? So geometry advances from periods of abstraction, periods of concretization, periods of abstraction, periods of concretization. That's how insights are gotten in geometry. That's also how insights are gotten in individual people in their individual minds. Okay, so to demonstrate that, I want to look real quick at this image. It's called the duck rabbit. It's famous in other disciplines, but I want to show how it can be used to demonstrate the characteristics of insight. So it can be used in a kind of phenomenology of epistemology. So this image shows two representations simultaneously. It shows a duck and it shows a rabbit. So it's called the duck rabbit. Now, we should note at the outset, you have prerequisite knowledge. You have to know what a duck and a rabbit is. And also, what you're looking at is not a duck or a rabbit, right? It doesn't quack. It doesn't eat carrots. It's a picture. It's an abstraction. So we're already in the field of abstraction, right? Removed from the realities of the world, using our prerequisite knowledge. Okay. Now within that, what I usually get if I'm in a classroom is I'll get several students who have who can see both objects right away, some students who can see one only, and some who can see the other only. And so what I'll try and do is I'll try and pick on one that that can only see one of the objects. I'll say, okay, which one can you see? And they'll say, okay, I can see a rabbit. And then somebody who can see both, I'll say, okay, can you give them a hint without giving it away? And what happens is you get all kinds of strange sentences. You get sentences like the ears are a bill, or the nose is the back of a head, right? And then I say, okay, well, let's pause on that sentence real quick, because that sentence doesn't make any sense out of context, right? If I were to say the ears are a bill, the what, right? That doesn't make any sense. How do these two ideas fit together, the ears and a bill? Normally they don't, but in this context they do. So what are we saying? Or like, I should say, by saying that ridiculous sentence, what are we trying to do? What we're trying to do is get the other person to reach into their prerequisite knowledge and pull out two abstractions and look at them say, okay, this is what I know about ears, and this is what I know about duck bills. And then they pivot up into the abstract. Okay. And then they pivot immediately right back down into the concrete, and they look at the image and they say, all right, ears, bill, ears, bill. And then sometimes in the first hint, sometimes after several hints, you'll usually get someone that goes, ah, I see it now. I get it. And that is the sound of them having the insight. It's a physical manifestation of the tension that the question gives to your body. So when they make that sound, I go, oh, you see it, right? And they say, yeah, I've had the insight. And then those strange sentences start to make sense. Okay. So the point I'm illustrating here is that to have the insight, that sensation of understanding, in order to have that, you have to reach into your abstractions, go back to your concrete image on the screen, in this case, up back to your abstraction, back to the image, back to your abstraction, back to the image. That pivoting is characteristic of that experience of going, oh, I understand this. Okay. So in just the same way that it's characteristic of the overall arch of the history of science, it's also characteristic of the particular insights of a particular person. So this kind of could justify us in going through periods of abstraction and concretization when we're talking about systematizing swordsmanship. So there's nothing wrong with axiomatic systems of abstract swordsmanship. There's nothing wrong with that. And there's nothing wrong with trying to take those axiomatic systems and concretizing them and putting them in different situations and seeing what emerges and seeing where the abstract system is correct, right? Where it has completeness and where it's incomplete, where it's either inconsistent, it needs something else added to it, right? In order to fill out, or it's just incomplete, right? We had some sort of false insight along the way, right? We iterated our operation wrong, that sort of thing. And we need to go back to the drawing board, so to speak. So we can go through these periods of abstraction and concretization. We shouldn't prefer one or the other necessarily. Except going back to Fiore's insight, going all the way back to this quote that we began with from Vadi. It says, "From geometry, all fencing is born." Now, recall that the goal of Euclidean geometry is completeness, consistency, and self-contained science, abstracted from the practical considerations. So just as Euclidean geometry did that with shape, I'm suggesting that Fiore may have done that with swordsmanship. That what he was aiming for was a complete, consistent, and self-contained science of swordsmanship, irrespective of the practical considerations. And then what that does is it gives him habitually or virtually practical knowledge of the entirety of the art of swordsmanship. Right, at least potentially. Now, we know again from the incompleteness theorem that that's never going to absolutely be the case. But if you understand what Fiore is getting at with his terms and operators, and you can devise these meta rules, there should not be a phenomenon that emerges in swordsmanship that you cannot deal with. Again, barring these unforeseen practical considerations like, differentiation in height, handedness, weight, physical ability, right? That sort of thing, right? All things being equal, you should be able to map out the entirety of the art. Okay, so in other words, as Vadi says, not only is all fencing geometrical, but all fencing is born when we start thinking about it axiomatically. It gives us a system that aspires toward completeness. Okay, so these meta rules will give you the roadmap for the entirety of fencing, hypothetically. Again, making allowances for the incompleteness theorem, right? Maybe making allowances for the fact that there's going to be things that we don't consider when we consider things abstractly, these material differences. Okay, so what does that mean? Once you come up with these meta rules and systems, you can map out in your mind where you are and where you need to go with the same level of certainty you would apply toward a geometrical proof, an engineering project, right? A logical proof, that sort of thing. You have the same certainty as your assumptions. Since you know that your body and their body can comport themselves in these different ways, you have that level of certainty that, and you've tested it, right? You've gone through the proofs and seen that these plays work. You have that level of certainty. No more, because again, if you're fighting somebody significantly differently shaped than you, but also no less certainty. Okay, that gives you a very clear roadmap of the entirety of the art. Okay, so as I said at the beginning, this project, this lecture, this talk, this insight had four main goals. The first was to provide an intuition into Fiore's geometrical basis. So did I provide enough examples in the requisite order? Probably I've exhausted I've exhausted examples in the requisite order such that you can see Fiore as doing something like Euclid did in his Elements. And you can see the analogy that these two works of art belong to something like the same genre. All right. If that's true, then number two, does that free us up to interpret Fiore's implicit rules and essential definitions, his meta rules, right? So that he's not just a bag of tricks, but a set of phrases meant to explicate these rules. So we can come up with our own meta rules. We can come up with our own pedagogies. We can feel free to include our own prerequisite knowledge, because that's all built into the kind of axiomatic system he was working with. Okay. Did we show that this was an ingenious move that was vastly ahead of his time? Hundreds of years in 100 years in terms of philosophy, to make habitually practical knowledge of a practical art, to think about a practical art in terms of complete impracticality. That's genius. That's genius. And then finally, to allow for to use that genius to sort of inspire us to allow for periods of abstraction of our own, whether that's in the study of Fiore or say you're doing KDF or Bolognese or what have you, that those periods of abstraction will forward your art in particular and the art in general. Okay, and then that's okay. And then so is the concretization. So is bringing it back into the concrete, and that these are things that Fiore would approve of. Okay, so if I've done my job, then these are the goals, and they have been accomplished. My hope is to continue doing these kinds of talks about different elements of Fiore and KDF, is particularly KDF. That's the one I'm more familiar with, but also Fiore. I think that there are more insights to be gleaned from Fiore's philosophical background, his way of thinking. And so this is my bibliography for sort of more details on this sort of thing, particularly the foundations of geometry and the history of mathematics. There's some good sources for that, if you're interested, although they are a lot of work outside of your swordsmanship. So thank you very much. I hope you enjoyed, and I hope to continue doing this, and so that we see each other again. All right. Thank you and goodbye.